Alright, if you're watching the video, go ahead and hit pause and try these problems, and then we'll go over them. So, first thing we have is we have the addition of a fraction plus a number. Let's make that a fraction plus a fraction, and we need to follow the rule of adding fractions require common denominators. So I have to times the top and the bottom by x minus 8, so that way it has the same denominator. And then what I would do here is take the top denominator, 7x plus, the top numerator, 7x plus 2, and I'm going to add to it the other numerator after I distribute 5x. So I get 5x squared minus 40x, and then we can write that all over the same denominator. Now, I'm going to combine my like terms up top. And I'm left with a single fraction. Now what you should do here is check that you might be able to do this in your head, but if you were to factor the top, you would multiply the 5x squared and the 2, and you'd get positive 10x. And then you'd think, well, are there any factors of positive 10x that add up to give me the middle term, negative 33x? And you might say no, but I'll just share with you kind of what my brain is going through. You do not have to write this part right here. But think about that. If I multiply the two corners, I get positive 10x squared. There isn't any way I'm going to get factors that add up to give me negative 33x, which means we can't factor this. And that's just confirmation that that's as far as I can go. All right, but you should always check, can you factor your new numerator? All right, number 2. First thing I would do is I do not like subtraction. That usually causes me a lot of errors, so I'm going to change that to adding the opposite of the second numerator. And then we're going to factor the bottom for each piece. So I get a 3 times x plus 4 for the first part, and then x squared minus 16 can be factored into x plus 4, x minus 4. So now we just got to play that game of I need common denominators. Well, the first denominator has a 3, the second one doesn't. So I'm going to multiply the top and bottom of the second one by 3. The first denominator doesn't have an x minus 4 in it, but the second one does. So I'm going to multiply the first fraction by x minus 4, top and bottom. Now, you can see, even though it's written in different order, each denominator has the exact same. Now my denominators are exactly the same. Which means I just have to distribute the 5 to the x minus 4. And then I've changed it to adding. So I'm going to distribute the 3 to the negative 3x and the minus 2. And then again, we're just going to combine the terms up top. And in my head, I'm thinking, okay, you know what? I got a new numerator. This numerator could be factored as 2 times x minus 13. But that doesn't help us at all because I don't have a factor of 2 or a factor of 13 that's going to reduce out. So in this case, I'm happy with the answer 2x minus 26 over 3 times x plus 4, x minus 4. If you wrote it and factored the top out in green, that would be acceptable as well. All right. quick review. Actually, I'm going to bring it back to geometry a little bit, just to refresh your mind here. What if I gave you this picture? And I will say I don't think this is going to be actually very accurate in terms of drawn to scale. But what do you know about those two triangles right now? Similar. By angle, right? And when we had similar triangles, we were able to compare the pieces that correspond. So what if I told you that this was 28, this was x, this side was 2, and this was 3? And again, definitely not drawn to scale. Remember when we set up the hypotenuse of one triangle compared to the hypotenuse of another? And then we had the short leg compared to the short leg, and we set up a proportion. Well, today, we're not doing the geometry side, we're just giving you the proportion. How do you solve that? What method would you use for solving? There's more than one way. Remember when we took the 28 times 3 and said that product has to be equal to the product of x times 2, or 2x? What was that called? Cross multiplying? That's one of the methods for solving proportions, is we can just cross multiply. I'll show you another method here in a second. If I multiply those together, I get 84 equals 2x. If I divide by 2, we get x equals 42. And then, as with kind of anything in math, we get an answer. We're not sure if it's going to be correct until we check it. I gotta put 14. 42. Well, 28 divided by 14 and 42 divided by 14 gives me 2/3. You could have also just grabbed your calculator and checked that the decimals were the same. Now, I will say this isn't the only way to do it. It's just a really friendly way that a lot of people are familiar with. You do not have to write this part here. I want to show you just one other way that you can think about this problem. What if we just apply regular solving techniques? Well, on the right side, I have 2 divided by 3. How do I get rid of divide by 3? We times both sides by 3. Okay, so that'll get rid of the 3 on this side. But then, same logic over here, I have a divide by x. So what if I times by x to this side? A times by x and a divide by x will go away, and I'm left with 28 equals 2 times x, which isn't that the exact same thing we had right here. So another way to think of it, it's just getting rid of the denominators. All right, so, and again, I'm not going to solve that all the way because we already know the answer. All right, that's actually one of the methods we're going to be using today is cross multiplication. The only difference is some of the problems are going to look a little different. We're going to have more than just an x, right? More than just a couple things going on. So I'd like you guys to try this one right now. My only hint when you're solving this is when you do cross multiplication, remember the 3x plus 7 is grouped together. So you should put parentheses around that, and same thing with the x plus 3. And I'll give you a minute. So my recommendation is sometimes students try to do too much in their head, and they make small errors when they do that. And I found that the students that try to multiply this by 2 in their head, and then try to multiply this by 7, every once in a while makes mistakes. So if you write this step that I just wrote, and then you do it, usually all those errors are gone. And the error that most often occurs is not multiplying the second piece in the parentheses. So we're going to distribute the 2, distribute the 7, and then now it's just regular algebra. I like to move this 6 over here, so I subtract 6 from 7 and I get 1x. By minus 21, we get negative 7. And then we're technically done, except for check. And again, you could do the check in your head, you can do your checking on your calculator. Officially, we're going to plug negative 7 back into every single spot there's an x and see if it equals 7 halves. So I would do this part of my head. I get negative 21 plus 7 is negative 14. Negative 4 plus 3, negative 7 plus 3 is negative 4. Negative divided by negative, and reduce by 2, and I end up with 7 halves equals 7 halves. If you typed it all in your calculator, you would have got 3.5 equals 3.5. But either way, that checks out, and it tells us we have an actual solution. So we could stop there and just say, hey, that's how you cross multiply. However, every so often we get problems that have a bunch of x's in them. And this process isn't any different, except for the solving piece is just a little bit different. So we'll do this one pretty quick here. I would set it up the same way. X plus 3 is grouped together, x plus 7 is grouped together, and then we're going to have to do our cross multiplication. So why don't you guys actually finish that once we had it set up. I'll have you guys go ahead, see how far you can get. So if I distribute the x, we get x times x, x times 3, distribute to 5, 5 times x, 5 times 7. Now we're at a spot where this is kind of like what we did in chapter 4. You have to move everything over to one side. I like to keep the x squared positive, so I'll subtract the 5x, which will give me negative 2x minus 35. And then we get to the point where now hopefully we can kind of factor this in our head. Factors of negative 35 that add up to give me negative 2. X minus 7 and x plus 5. And then we want to solve each one. So if I think of what makes those 0, I'll get a positive 7 and a negative 5. Now, we're not sure, especially when you get 2 answers, that always makes me kind of wonder. Well, let's check. Check x equals 7. And again, you could do the part of this in your head. If you plug 7 in for x, 7 plus 3 is 10. Plug 7 in the bottom, you get 7 plus 7, so that's 10/14. Does that equal 5 over 7? And you can see that that's going to reduce down if you divide by 2. So I know x equals 7, so 7 works. And then we'll do the same thing with x equals 5. If I plug 5 up top, I get 5 plus 3 is 8. 5 plus 7 is 12. Oh, negative 5. Sorry. I knew something was wrong. Didn't feel right. I'm checking a negative 5. So negative 5 plus 3 is negative 2. Negative 5 plus 7 is 2. And then 5 over negative 5, I get negative 2 over 2, which is negative 1. 5 over negative 5, which is negative 1. And that also works. So I have 2 true expressions. All right. I don't think we need to write this down because my thought is we've already done this in geometry with proportions, cross multiply, but officially this is one strategy for solving rational functions. I want to show you just one extra little thing with this problem we just did. You do not have to write it down. See if I can grab this quick. Oh, it's already done there. What if I gave you the problem we just did, but I changed it a little bit? Okay, everybody look up here. I just want you to notice, what if I took this 5 divided by x and I moved it over to the other side? So it would look like this. So what if I took it as positive? What if I subtracted it over to the other side? If I would have given you this problem versus this problem, that looks a lot harder, right? But it's a fraction minus a fraction, or even if you have a fraction plus a fraction, if it's equal to 0, you can move the other side over here so it looks like a proportion. And that's just a little technique, a little skill that potentially may appear every once in a while. Now, we're going to teach you another method for solving this today. I just wanted to quick make you aware that that could happen. Here's what we have here. What if, now before you start writing, look at this problem. I can't cross multiply with the style that it's currently set up in, right? Because I don't have a fraction equaling fraction. I don't have a proportion. I have 2 fractions added together equals another fraction. Now, there's 2 options I could do. I could add these 2 fractions together, because we now know how to add fractions from what we did on Monday, and then they'll equal 7 over x. And if I do that, then I can cross multiply. But it's actually a lot of work. There's a faster way to do it. And the faster way to do it is strategy 2, and that's what we're going to focus on for the rest of the day today. Clearing the denominators. How can I get rid of these denominators and help solve the problem? So what I'd like you to do is just go ahead and write this strategy down, and then we'll do this problem together in a minute or two. What's the goal with clearing the denominators? Well, the first thing is we're going to talk about the least common denominator, or sometimes we call it the LCD. Once we have that, we'll multiply both sides of the equation by the LCD, and you're going to notice that that's going to clear the denominators, hence the kind of the name of this strategy. So it'll get rid of all the denominators, and all that's left is just regular algebra problems. So, when we do this example, our goal is to first discover what is the least common denominator. And the quick way to do that is just look at each denominator. I've got an x, a 5, and an x. Well, if there's more than one of the same thing, we're only going to include that once. So my denominator has to have an x in it for sure. Okay? And it has to have anything else that is missing. So it has to have an x and it has to have a 5. But I would prefer to write that as 5x. And there's my LCD. Now, this first time we do this problem, it's going to be just a little bit annoying, because I'm going to show all the proper steps. So what do we do now that we have the LCD? We need to multiply the entire thing by 5x, which is all of these pieces are multiplied by 5x. But keep in mind, it's 5x over 1. So that 5x is going into the numerator. Right? So when I distribute, each one of these pieces is going to be multiplied by 5x. So I'll times by 5x up top for each one. And notice I could multiply all the bottoms by 1, but that doesn't change it. So now, why is that helpful? Doesn't that just make the problem more confusing? Well, let's look at what it does. If I multiply every single numerator by a 5x, notice how the 15 times 5x is divided by an x. This x is going to reduce out with that x, and all that's left over is 5 times 15, which is 75. And then I've got 4 times 5x divided by 5. Well, this 5 is going to reduce that with this 5, and all that's left over is a 4x. And same thing over here. I've got 7 times 5x divided by x. Well, this x in the denominator is going to reduce that with the x up top, and all that's left over is 7 times 5, or 35. And you'll notice, by multiplying by the LCD, it gets rid of all the denominators. They're cleared. They're gone. It's just algebra. Now, hopefully it's a much friendlier solving process than it was originally. I'm going to subtract the 75, divide by 4, negative x equals negative 10. And of course, we're not done, right? We're not done until we check our answer. I will show you one thing here that often kids kind of forget about. If I'm going to plug in negative 10, I could grab a calculator and do this, or it's actually kind of nice to review fractions. What if I take and times this one by 2? Now keep in mind, this is the one thing, this negative means the whole fraction is negative. So I actually like to think of a fraction as having the numerator negative. And then here we're going to times this by 2, so I get 8 tenths. And negative 15 plus 8 tenths is negative 7 tenths, which is equal to exactly what we thought it was. Which means we end up with an accurate, true solution. If you did it in your calculator, you should get negative 0.7 equals negative 0.7, which proves the same thing. Okay, so I'll admit, you really do not need to show this first step right here. Mathematically, that's what we're doing. We're multiplying everything by the LCD. But what I'm going to do is just kind of jump right here to reduce the amount of work. So let's try it with this one. We'll do this one together. And then I think I got one more for you guys, 1 or 2 more for you guys to try on your own. So I'll give you a second to write this one down. So the first thing I do is actually notice the subtraction. I do not like subtraction one bit, so I'm going to change this to adding the opposite of that numerator. that, by doing that one step, that reduces a ton of errors. Then I want to look for my LCD. Now keep in mind, I have x. That's the same as x over 1. And the LCD is, what do they have in common? Well, I've got the factor x plus 1 in 2 out of the 3 fractions. So we're only going to write that once. X plus 1. And then I have anything else which happens to be 1 is officially part of my LCD, but does times by 1 really change it? No. So my LCD is x plus 1. So now, instead of doing that first big step, what we're going to do is we're going to multiply each top by the LCD. Each numerator is being multiplied by the LCD, and I would throw parentheses around the -2 x plus -2. And before you get too crazy, our goal then is now we're going to reduce things out. The title of this method is canceling the denominators. Well, if I multiply everything by the LCD, then I have an x plus 1 on top and on bottom. So what's left over is just the x. Same thing here. We've got an x plus 1 on top and on bottom. And what's left over is -2x plus -2. The only spot that doesn't reduce out is the x times x plus 1. So then we're going to distribute. I get an x squared plus 1x. Look at the denominators are gone. Now it turned into a regular old algebra problem that you guys have solved a ton of times. So actually, here's a small hint for solving this one. Instead of combining all my like terms right away, see how there's this x on the right side? If I subtract an x here and here, those are gone. So it actually helps simplify just a little faster. And then hopefully this is factorable. Factors of -3 that add up to give me -2. Or -3 and positive, -3 and positive 1. And if I set each one equal to 0 and solve, I would get one answer being x equals 3 and the other one being x equals -1. Now, we haven't really seen this come up a lot yet, so let me show you something that could be really helpful and a time saver for you. Look at your two answers. Is there one of these answers, or maybe both, that you know right away without showing any work, which one of these is not going to work in this original problem? Kristen? Why? Awesome. Notice, if we look at -1, and I plug -1 in right here, or right here, it doesn't matter, or both of them, -1 plus 1 is 0. Can I divide by 0? No, that's one of the 10 commandments of math, right? Can't do it. So you don't have to show any work, and you can quickly identify that that is an extraneous solution that's going to produce a false response. Right? Now, unfortunately, we can't really do that with the 3 because I can plug 3 into the denominators. So I still have to check that 3. And that's where you can do as little or as much work as you need to. But let's kind of quickly check 3 here. I'm going to do some of this in my head. Like 3 times 2 is 6. 6 plus 3 is 9. Over 3 plus 1 is 4. and then I'd get 3 over 4 here. Again, you could grab your calculator, or you could think of 3 as 12 fourths. 12 divided by 4 is 3, and that just allows me to say, oh, well, 12 minus 9 is 3 fourths, and that's equal to exactly what we want it to be. So I know that x equals 3 is a solution. All right, I got one last one. And I'll mention this. This year, we're making it not super challenging just because we don't have a ton of time. But in a normal year, we'd spend another day on this, and we would have a lot more challenging pieces where your LCD has multiple pieces. The nice thing is the process doesn't change. So, all right, why don't you try this one? All right, let's just double check this one. So I notice my LCD is just x plus 7 times everything by the LCD. And then I'll notice that the x plus 7 on top and bottom will reduce out. So I just have the negative 1 left over. The x plus 7 on the right side reduces out. So I'm left, oh, shoot. I made an error. This negative got me right here. That should be a negative 4. Which is going to probably change the rest of my answer. I'll double check that here in a second. And then negative 5 times 7 and x gives me negative 5x minus 35 minus 1 equals negative 4. So that is going to definitely change my answer. And if I plug this in and add 5x over, I get a 1. Which means x is equal to negative 36. All of this work is for naught. This might even be one that I definitely just grabbed my calculator for. But I'm going to go back to the original problem, and we're going to plug in negative 36. And then I'm definitely not going to forget that negative. That should go there. And if we get something like 144 over negative 29, and then I would just do this in my calculator, turn that back into a fraction, and you end up getting the same. So, be careful with negatives. I just showed you. I don't love the way it was just kind of written right there, but be careful with subtraction or negatives. I think that was the reason why I originally put this on here, and it got me. All right, what do you think about that? Feeling pretty good on it with clearing the denominators? Okay. If you didn't like that, one thing you could do is you could have added these two fractions together just like we did in the warm-up, and then you would have a fraction equals a fraction, and you could cross multiply. The thing that I like about this method here is a lot of times it can get rid of extraneous solutions for you and just make them not present versus cross multiply and nothing reduces out. So what we've got then tonight is delta math, rational equations. If you brought your Algebra 2 textbook or geometry textbook into school today, we'll drop that off in the afternoon. Those of you on Zoom, if you're coming to school at all, Monday through Friday over the next week or two, or 3, bring in your textbooks if you're not using them. We're not going to use them anymore. So you could do that. All right, that's all I have. Have a great